Hello and welcome back to the lab. Today on the bench we have a giant box. This is something that's come to the lab recently and we are going to take a look at it. Kind of excited to get this added into the inventory of useful test gear. We actually have another tube tester. Let me reposition the camera and I'll give everybody a better top-down view. So once again, thank you for everybody joining us here in the lab, and thank you for the patrons who help keep the lights on and the videos coming. You guys help way more than you even know. We had a very large influx of tubes into the lab, and by very large influx of tubes, I mean I have been sorting vacuum tubes for literally 3 weeks. And so I have to get some tube testers up and running because I now have a ton of tubes that need to be tested. So I figured I'd get this guy off the ground. It's a KS-15560-L1. This uses the Hickok circuit, so I imagine what we're going to find in here when I take this apart is we have, we'll probably have an 83 and a 5Y3, and this is also quite heavy, and it has more gauges, or more meters than my Stark. My Stark doesn't have a bias volts meter to set bias for tubes, and it also doesn't have a it does have a power meter, but not a dedicated power meter. It uses the meter for line adjustment. So the other thing that on this tester that you have to be really careful with is on the tube test function, there is a locking position and there is a non-locking position. So you can burn out a tube on these if you leave them in the lock position for too long, because it's really pulling on the tube. So don't want to do that for too long. We also have a self-biasing resistor if we need it. That's what this is for. For DC bias, grid and plate, there should be, yep, it's right here. For grid and plate cap. And then we also have a noise test. My other tube tester has a noise test as well. I need to figure out exactly what headphones I need to get this working. If anybody knows what kind of headphones I need, let me know in the comments and I will get some in the lab. We'll have to clean this off. This looks like this tube tester's seen a lot of use. The roll chart is polished. So this has been this has seen some time. Normal and test, when you kick it into test, it drops the filament voltage by 10% to give a life estimate of the tube. That should be okay. The other tube tester we did was pretty simple, so I'm hoping there's not too much we have to do in here to get this up and running. But we'll see. It's missing a lot of hardware on the front, which is fine. And I've also noticed there is a bit of oddware. This is always good to see when you see a line sticking out of the power cord. Now this is a 2-wire power cord. I'd probably guess this is ground, but I don't necessarily want to trust it. We will be doing something about the line cord. Hopefully the sockets are okay. I do need to replace on the Stark. I need to replace the 9-pin socket, because it has been well loved. But that one's for another day. For right now, we're on to the 15560. So what we'll do is I'm going to turn this sideways, and then we'll see if it'll come out. If it'll pop out, cool. If not, we'll see if there's any hardware I need to remove. Looks like a lot of the hardware is missing around the sides. So we'll definitely probably get some nice stainless hardware for it. And go from there. We have serial number 207. And this is made by Hickok for Weston Electric. What will we find? Oh, it's coming out. Very cool. This is really heavy, actually. Surprisingly heavy, considering what the other one was. Let's see. Oh, well, that's pretty convenient. Okay, so we have a 83 and a 5Y3. We also have some selenium rectifiers, which is odd. We actually have 2 power transformers. This potentiometer and that potentiometer are critical components, it actually looks like, at first glance, it does look like this coil has been hot in the past, so I'll have to check that for continuity. Just make sure that coil's okay. All the other coils look fine. They're not discolored at all. These resistors look fine. I'll want to replace this capacitor. These caps probably need to go. These caps probably need to go. This cap definitely needs to go. That's a wax. The switches and everything need to be cleaned up. That's not awful, but this one's actually quite a challenge because the switches aren't flat like in the Stark. They're a stacked switch arrangement. So lots of switches to clean. But this 83 doesn't look too hot. I want to test that before I put power to this and go much further. So let's get these two tubes out and let's get the Stark, and we'll test this 83 and see what's going on. Okay, so the 83's data for the Stark is in the additional supplement manual. This is the roll chart printed. Then I have a supplement, a couple of supplements actually. They made 3 of them, I think. I have them all in pages in this book. So for the 83, not to be confused with the 83V, we're at 5 volts of filament. We're on JR, and then we are on 0, 3, 0, 0, 0, suppressor grid. The bias is 0. The English is 70. And we need to put the tube in. And we need that set to English because we're testing a rectifier. And there's a lot of, you'll notice mercury. This is a mercury vapor tube, so there being mercury in here is not necessarily a bad thing. But it's sticking to the glass, which is not good because mercury typically doesn't wet glass. So if it's wetting the glass, that means there's a lot of impurities in it. So I'm actually kind of worried about this tube. Filaments are lighting up, so that looks good. Give it some time. Let's see. Line adjust. We'll get that right on. Line test. And it's P3 for diode, and we want diodes okay to be past the line for diodes. So, oh yeah, check for shorts, which is here. If the bulb lights up and stays lit, we have a short. So no, 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 and no. Brief flashes are expected and okay. And we are on normal for the test, not life test. The life test on this Stark, which is right down here, that is the same thing, drops the filament temperature by about 10%, or drops the filament voltage by about 10%, and sees what's happening. So we hit P3 for rectifier, and we watch the needle. That side is good. That's actually this side of the tube. So on the left side, we have a pretty healthy rectifier. So I might be wrong here. To test the other plate, we bring the bias to 65, or the English to 65. Bias is still 0. And we switch plate to plate number 2. That'll switch it to the other elements in the tube. Second, and That's actually testing okay too. Let's see. Right over on the scale, 2,000-ish. 2,200. So we'll kick this back up to 70. We'll go down to 3. And actually, they're pretty nicely matched. So this 83 is actually doing okay. We can put him back in the tester. And if I don't have to do a solid state equivalent, that might be good. 83s are getting really expensive, like stupid expensive. So, let's see, 2, line adjust, we're still good. 65. Yeah, okay, so this one is actually rectifying okay, which is also good. I mean, when they unless I push this button, the 83s are very lightly loaded in the circuit, so they do run okay. Well, let me zoom in on it. I've dimmed the lights in the lab so you can really see the filaments glowing on the side. If I shut this monitor off, the thing will go away. But if you take a look right inside that filament, I don't know if this is going to show up on camera, but I'll hit the rectifier. Oh yeah, it does. Let me get above it. This is something really cool about the 83s. You can actually see that glow is the mercury vapor. And you can actually see the tube rectifying. That's in response to getting excited. So, and then if I hit, if I switch it over to number 3, turn the English back up, and then we hit rectifier, the other side will glow. So, very cool. But this 83 is fine. Let's check the 5Y3. Okay, for the 5Y3, I have the tube tester turned off because I wanted to check the filaments before I plug the tube in. The 5Y3 is found in the main roll chart, which I also have a printout of. Let's see, the 5Y3 is 5, and then it is HR 0, 6, 0, 0, 0, 0, and 22. Turn it on. Let's let the tube warm up. Oh yeah, it's glowing. Check for shorts. Nope, that's fine. And does it rectify? Yes, it does. Back this off to 18. And then we turn this to 4. Does it rectify? It does. No nice blue glow. Should have checked that for shorts before I hit the go button, but I am still learning this tube tester. If you have a short in the tube and you hit the go button, you can damage the tube tester, so it's always a good habit to check for shorts before hitting the test button. But this is also checking out okay. So my 2 rectifiers are okay for the unit. So let's get start working on some capacitors, because for sure those need to be redone. It'd be nice to test these 2 units against each other too, because this particular unit does not have its 83. This has its solid state rectifier version. But I'll be very interested to see how a tube tests on this and then immediately tests on the other tester based on versus the 83 versus the solid state. So that will be an interesting experiment once I get that guy fixed. Now we have a very interesting line cord going on. Here's our line cord coming in, and we have a ground connected, but we don't have a ground at the plug, I'm assuming. I haven't checked it yet. But then we have the positive into the switch and the return into the line adjust pot, which is normal. But the other thing that I'm not seeing on this particular tube tester is I am not seeing anything regarding calibration points or anything like that. So I really hope nothing's wrong and everything is working, because it doesn't look like there's going to be a way to tweak things if it's not. We have some creative positioning to get to this capacitor that's on the back of the meter. I've got everything all, it's sitting securely, so it's not going to fall, so I need to get this cap out and a new one in. With the capacitor hiding behind the power transformer, this is exceptionally difficult to get at if you don't get at it from the front side. So we pop the meter off, 4 screws, and it comes out. All's good. And we'll get the new one mounted in. I'm going to work on the screws for the meter because they came out, so the meter wasn't really fixed in very well. So we're going to get that fixed when we get the capacitor fixed. And I'm going to clean. Yes, we're going to look at the difference in color. So this has seen a lot of use. So we have factory exposure, because the meter face was right here at the corner. So we're gonna clean all this up while the meter's out. Okay, we've got our new electrolytic cap put in. This is also an electrolytic. It is a 50 microfarad by 6 volt DC, and it was in this way. So we do have a polarity, plus and minus. So the new cap, since this is protecting the meter movement from surges and things like that, it is now a 57 microfarad because the value isn't 100% critical. And 100 volt DC because that's what I had in stock. So way overkill for this position, but it'll work. For the self-biasing capacitor here, we have a 2200 microfarad 10 volt DC capacitor with negative being pin 1, which was in like this. So we have our negative stripe over here. We have another horrific bit of overkill. This is 2,000 microfarads at 10 volts, working volts DC. We have a 2200 microfarad at 100 working volts DC. So this should never end. It's also a 105 degree C cap, so it should never fail again. Next up on the list of replacements is this wax capacitor right here. This one's going to be tricky because I have to do it around all this wiring and the switch pack and everything like that. So this one's going to be interesting. But we'll see what we can do. And some people tell me wax caps are still good. This thing is waxed out all over the place. And that giant wax capacitor gets replaced with a tiny ceramic. This is actually a pretty critical cap in the circuit. If I remember correctly, this is the short switch. So this is the cap that actually helps drive the neon light in the short circuit. As luck would have it, this coil is testing okay, so that's good there. And what look like capacitors up here are not. These are actually resistors. So it's weird that they have a resistor and a resistor in circuit, but this is a 5-watt resistor, and then we have some other resistors on top. The selenium rectifiers tested okay, so I'm actually going to leave them in for now. And we do have a 3-pin line cord. We have ground and white and black. So we are going to address the plug here in a moment. Okay, first fire up after the rebuild. Let's see how we did. Well, the fuse came on for a little bit and then went off. The line adjust is allowing me to adjust for test. I have some bias voltage. Very cool. All right. Wow, it's drawing far. Is it 40 watts? We're drawing about 48 watts. So much better. Yeah, I have a significant adjustment in the Line voltage on the transformer. That's fine. That's working. All right. We're in normal mode. Meter's okay. Let's do some mechanical zero on the meter. Not that it matters because these aren't hyper accurate. These are not laboratory grade tube testers. These are essentially go, no go. So they're not crazy. Let's get a 6L6, just a power tube. Throw it in here and see what happens. Okay, we have a Sovtech 6L6. And let's see. Let's set up the tube tester first. 6L6. I'm going to print out the roll chart so I don't have to mess with this because this has been worked pretty hard. But for now, 6.3 volts, which we are at. JR 53472. Bias volts is 3. Oh, way up. And test volts, test is on the test line, so we will pop this in like so, and then we'll have to readjust the line. Line test, yep, we are bouncing. We are running right around 120, so that meter is reading correctly. Let this tube warm up. Hey, we have filament glow. We are on high, and it wants us to be on the 1500 scale. And it wants the bias volts at 3. Oh, micro ohm switch or shunt, high 15, and it doesn't matter what our shunt is set for because it is not used at this time. So, check for shorts. No shorts, tube is good, and we were getting blinks on the shorts lights, so my capacitor's working just fine. That other cap was dead. Like, beyond dead. We're going to do P4 no locking, and I need a minimum of 3600 transconductance. This is a single element tube. This is a power tube, so there's not a one section, two section. It's just what it is. So we're going to hit here, and we are on the 1500 scale, so we're looking for the needle to come up around here. This is a very good performing tube, actually. We're above 5,000. I needed a minimum of 3,600, but the tube tester is working. Let me zoom in on the meter. Okay, you guys are off to the side, so parallax error and all that good stuff. But here we go. Bias volts 3. Bias volts are running way hot. Line test. Yep, we're good. Okay, we're good. And boom. There we are, above 5,000. So the 1500 scale is the third one down. So we're running 55-ish, 5,600. So, well, very well performing tube, and very well performing tube tester. So, what's left to do? Got to get some hardware and get this fixed back in, and then we definitely have to address that line cord. So I'll get that done. I'm going to do a little bit of cleaning on the front end now that we know everything's working, and I think that's actually going to bring this one to a close. So, oh, and the shorts capacitor, it was a 0.1 microfarad at 400 volts. It's now a 0.22 microfarad at 630 volts in a ceramic, because I wanted to keep it because it's in an AC position. I wanted to keep it non-polar, so I couldn't use a electrolytic there. I might have forgotten to do something. I was thinking about the this tube tester last night, and it crosses my mind that there's a cap that I haven't replaced yet. So before I put the hardware back in, let me let me take a look and just confirm all the electrolytics are gone. We'll go from there, but I think there's one more we have to do. And it does appear that I was correct. There's one hiding right here underneath. So we'll get him out, and then we'll be good. Okay, got the capacitor replaced. It's hiding underneath. It is a much higher quality capacitor than this guy right here. This is 100 microfarad at 50 volts DC. We went in with 120 by 100. So again, a little bit of overkill for this tube tester, but everything is good. Okay, moment of truth. I have it hooked up to the power monitor. Everything's good to go. And we're settling back down, and we're drawing a decent wattage, which is very good. Actually, our line voltage is running a little hot, so load on the transformer's lighter. This should still be set up for the 6L6. Let's get that and give it a test. Okay, we have our 6L6 in there. And we have filaments. Everything looks good. No shorts. That's all happy. Yeah, so everything is good. All right, I'm going to let this just sit and burn for a while without any load on it, just to make sure we don't have any shorts capacitor problems. I'm going to clean this up. Going to get some hardware tomorrow. And I'll deal with the power plug, and I will also deal with cabinet hardware. Okay, we have the ever-present 6L6 that we've been using to test this tube tester all along. Just check it for shorts one more time. I doubt it, but we'll see anyway. Yep, we're fine. Just the line volts and the bias. We're on a good 3-pin barrel plug now. Ground is hooked up. Everything's good to go. And let's see what we get. Same thing. So it's not, so the ground being hooked up is not affecting the testing at all. I didn't expect it to, but I just wanted to confirm. Got some nice hardware in the sides now, and everything is good to go. So this unit is actually done and ready for the bench. I'm going to get the cover back, put back on this, and put this off to the side and get into the next repair. So thanks again for stopping by the lab. If you have not done so and are still here, please subscribe. And as always, more is always on the way. I do check all the comments. And if there's anything you'd like to see me put in front of the camera, definitely drop me a line and we'll see what we can make happen. More is always on the way. So I will see everyone in the next video.